Based on spectral analysis, how to find out the structure in easy manner. For that, I am going to give you a small clue about this particular question. So don't by heart the interrelational data, just focus on IR and HNMR spectroscopy. You can ignore C13 NMR spectroscopy sometimes. Without this data, we can find out with the IR and HNMR spectroscopy also. So how it is possible? So for that, I am going to give you small clue. So small hint for this particular question. So just watch it till it complete. So in IR frequency focused on for user to identification of functional group, which functional group is present in the molecule. So main theme of IR spectra. And HNMR means identification of which protons are connected with the different chemical environments. So those are the things which we have to understand or which we have to remember for solving problems. So here now focused on IR's data. So how to find out in easy manner. IR spectra is given 3485. This is our CH stretching frequency. So CH means it is not a functional group. Okay, so this main theme is for finding functional group, which functional group is present. So 1745, this is the frequency, approximately not, so but accurate value for frequency is ester group. Okay, so ester group means C double bond O R. This is the ester group, so we can find ester group here. And HNMRs now see, so 1245 to 1043, that means here C double bond O group is there. So ignore that and just focus on this functional group. We can find functional group here. And now which type of protons is connected with this ester group. So here the given data 1.98 is a singlet and 3.6 is a singlet. So these are two values as given in this problem. So singlet means only there is no neighboring protons, that means it is CH3 and CH3. So connection will be, so there is no connection with the neighboring protons. Now we can write it as, so in the place of R we can write it as CH3 and CH3. So this is a methyl acetate. So we have another oxygen here. So methyl acetate in the place of ester group and two methyl groups. So methyl group is not connected with any kind of neighboring protons. This is also same. This is connected with oxygen. This is connected with the carbon. So both are different chemical environments. So this is A and this is B. So two types of signals are present and two protons are not same. So two methyl groups are not same. They are differently arranged. So this is the structure for above problem. So we can find out easy in mass spectral fragmentation. Mainly theme is as long chain increases, so base peak value also decreases. So we can find the weight of the compound in mass spectroscopy. In HNMR we can write it as which more electronegativity groups there in carbon, connected with carbon. So those are higher value in C13NMR. So ignore that and just based on IR spectroscopy and HNMR we can find out easily which type of structure is present. So another structure we can see, so this is the methyl acetate. Okay, methyl acetate in shortcut MA. And next problem we can see that part 2, problem 2. So just focus on IR and HNMR, ignore the C13NMR spectra. So in IR spectra we can find 2985 to 2845, that means here CH stretching means not functional group, CH stretching is there. So in 1720, that means 1715 to 1720, here ketonic functional group is present. So what does it mean? Means ketonic functional group is present. So ketone functional group means C double bond O group is there, right? Or we can write it as like this. So we can find the functional group here. Okay, and we can go to HNMR. 0.99 is a triplet and 2.07 is a singlet and 2.42 is a quadret. So what is meant by triplet and singlet and quadret? So triplet means here CH3 is connected with the CH2 So here CH3 is the neighboring proton is 2. So as per n plus 1 rule, so 2 plus 1 is a triplet. It can act as triplet. It is as a quadrat. So when it is neighboring, it is quadrat. When it is neighboring to this CH2, so this is a triplet. So singlet means this is a CH3. So we can write it as here. So CH2 and CH3. So this is a triplet. This is a quadrat, and this is a triplet, and this is singlet. So this is a structure for this 2-butanone. So this is a easy to remember and easy to find out. So based on IR data and HNMR data, we can find out the structure. So just you can write. So in IR spectra, for example, you can find IR spectra. So the ketonic group. So C double bond O group, you can write it as beside. And next go to HNMR. So you can calculate triplet means you can CH3 is connected with CH2 or CH2 connected with CH3. This is a quadrat. 2 is solved. Triplet and quadrat, you know that. And then singlet means CH3. So there is no neighboring protons, means here CH3 is connected with the only carbon double bond. So this is the right structure for the 2-butanone as a given problem. Okay, so whenever you solving the spectroscopic problems, so you can find out easy with by HNMR and IR data. Only sometimes you can go for the C13 NMR. Okay, this is the easy to find out the structures. Your semester exam also, it is very important, and see this for CSR net also, it is very important. Thank you guys for watching this video.